So chapter 11 review part 1, we're going to start our review with review of parametric equations. What do we have? Find Cartesian equations, sketch a graph, make sure you show direction. And here I notice that x is s squared of t. I could simply use substitution, and that's how it looks like. At 1 with a slope of 1 down, 1 to the right, the line should look something like this. And again, we're using a line that's hard to see because we're not going to take this whole path, we're going to take a portion of it. So as it is, we know that x is always positive and y is going to be less than 1 all the time because square root of t is always positive. But we could just start with t equals 0, and that pretty much gives you a few points where you start and which direction you run in. X would be 0, y would be 1. So we're starting right there. This is where we are right now. When t equal 1, I am at 1, 0. And of course, I could check not 2, 3, 4. We want perfect squares because we have a radical, and that would be a 2 and a negative 1. So we can figure out that this is going to run in this direction, and that's not even there. And that's pretty much it for this problem. Next problem up, and we dealt with those before. We know what those look like. Anytime you see a combination of trig, you're going to have to use the Pythagorean identity or some form of identity, and you square both sides. And here. And if you square both sides, so we knew this was a circle. If you add both sides of the equation, you're looking at x squared over 4 plus y squared over 4 equal 1. 2 in the x and 2 in the y. And draw your circle. Now we're not sure if we're going to get the whole circle or not, but we'll figure that out in a minute. And now when I get to it, I say, okay, at t equals 0, where am I? So do not mix up that 0 to 2 pi means really this top portion of the graph. That's not true. 0 to 2 pi, you have to plug those in. At 0, I am at negative 2, 0. T equal pi over 2, I am at 0, 2. So I figure that we're running in this direction, and by the time we hit pi, cosine of pi is negative 1 times negative 2, that's a 2, and sine of pi is 0. So we do trace the top half, and it's just a coincidence that it matched. But the direction is negative, and of course, we don't need that. And that's pretty much what the graph looked like. Here, I know this is an ellipse. We've already done that. And to really convert, we're going to have to isolate the trig function by itself again. And if we square both sides, wait, was that a 4 or a 16? No, that was a 2. Okay, good. And here, y over 9 equals sine of t, and if you square both sides, you get y squared over 9 equals sine squared of t. And if I add those, I'll get x squared over 16 plus y squared over 9 equal a 1. And what that indicates that I'm going to be moving 4 in the x, 3 in the y, and if I was able to get the whole graph, it would look something like this. Now I need direction. I start with t equals 0. Cosine is 1, that's 4, 0. I'm starting right there. At pi over 2, I am at 0, 9. Oh, time up. Something's not right. What's not? Oh, I messed up. Oh boy. When you square both sides, this is over 81. So I'm going to move 9 in the y direction. So that's 2, let's say that's 2, 4, 6, 8, 10, 9, and 2, 4, 6, 8, 10, 9. So we're going to move 2, 4, 2, 4. There. So that the graph looks realistic. It's stretched along the y, not the x. So we don't want to rescale. And again, I go back to the starting point and I start looking at what we did. We started at 4, 0, then we are at 0, 9. So this is running like we expected to. At t equal pi, I really don't need to go on because I know that that's the direction. And since it's running 0 to 2 pi, I am aware I'm going to trace the whole thing. Number 8. Find a parametric equations and a parameter interval for, you want a graph to start at negative 2, 0. Oh, because I shifted that, everything's out of sync. You want to start at negative 2, 0. We know this is a circle. So we know it's going to look something like this. We want to start right there at negative 2, 0. And we want to go 3 times clockwise. And clockwise would be in negative, in positive, no, negative rotation, right? So if we let x equal twice the cosine of negative t, and y equal twice the sine of negative t, that'll do the trick. But since cosine is even, it'll absorb the negative, and y is positive. And we know this from the previous homework that if you wanted to run in the opposite direction, you just have to switch t. Now we already know that if you let t run between 0 and 2 pi, you will trace the curve, and you could check. If I run this to 2 pi at t equals 0, I am at 2, 0. So I'm right. Oh, I want it to be at, oh, I want to start at negative 2, 0. So I'm going to make, oh, that I didn't pay attention to. Let me think about that. Okay, well, now that I see this, again, there are multiple ways of doing this. This is just like number 4. Number 4 started at negative 2, 0, if you recall, and it went in this direction, and it was x equal, they made this negative, and we're going to keep this positive. Now 0 to 2 pi is going to get me 1 full cycle around the circle, but we wanted to go 3 times, so we multiply those by 3, and we say let t run between 0 and 6 pi, and that should do the trick. And how about this problem? Okay, they want us to find an equation for that line in the xy plane that's tangent. If t equal t, x will equal 1 plus 1 over 4, that's 5/4. And y would be 1 minus 3/2, so that's 2 minus, that's negative 1/2. Right, so if they want us to find an equation of a line, that's y minus y1 equal m into x minus x1. There you go. And how does that work? Derivative, we know that y depends on t and x depend on t. Derivative of y will be 3 over t squared. Derivative of x will be negative 1 over t cubed, negative 2. That's t to the negative 2. Bring the power down, subtract 1 from the power. That's negative 3 t to the negative 1. Yeah, that works. If I evaluate that at 2, I'm looking at 3 over 4 over 2 over 8. So that is negative 3 times 2 over 2. That'll be negative 3. Now they want us to find the second derivative that's provided on the formula sheet. You really don't have to memorize this. The second derivative is the derivative with respect to t of the first derivative divided by dx dt. And I'm going to clean that up. I should have did that. The first derivative was right there. So that was 3 over t squared times t cubed over 2. That was really negative 3/2 t. So derivative of that would be negative 3/2. Now dx dt is right there. Or you could take a derivative of this one more time. That's negative 2 over t cubed. So that's going to be, again, a positive now. 3/2 times t cubed over 2. So that's 3t cubed evaluated at t equal 2. The second derivative will be 3 times 2 cubed. That's 8. That's 24. And that would be it. I made a mistake on the previous problem right there. Those two right there. When you multiply those, they don't cancel out. That turns out to be a 4. So you end up dividing this by 4. So this ends up being a 6. Good thing I caught that. Okay. Find me a parametric equation. Again, for 2140, this is a must. You really have to do these problems. So find a parametric equation for a line like this. They say the line through with the following slopes. If I use y equal mx plus b, y equal negative 2, when x equal 1. So I could say y equals 3x minus 5. To make that a parametric equation, that's very simple. Let x equal t and put a t in there. Y will be 3t minus 5. Now, the limitation on t will be depending what you let equal t. In this case, they said a line, so there's no restriction. So t could be anything. And the limits on t are a must as well. So, next equation. I want to find the parametric equation for a circle. Now, they're not specifying how this looks or direction. But I could say, and we know that, we could take x minus 1 and set it equal to 3, the cosine of t. We did that a few times already. So x is 1 plus 3, the cosine of t. And we could say y plus 2 should equal 3, the sine of t. And y would be negative 2 plus 3, the sine of t. So x equal 1 plus 3, the cosine of t will do. And y would be negative 2 plus 3, the sine of t. And if I just want a circle, I could run it from 0 to 2 pi because they didn't specify. And there's my answer. And this problem is fairly simple. And how is that? Well, they didn't specify. Let x equal t. And what's y? Replace x by t. Isn't that 4t squared minus t? And t would be no restriction. Now, again, when the time comes, you want to write that as a vector. That's not the scope of this class. But to write it as a vector, all what you have to do is write the x component first, the y component next. And you could do that on each one of those and make them vectors. And that's what you're going to have to use in your next course. And how about here? Well, if I make that a 1, wouldn't that mean that I'm taking x squared divided by 4 plus y squared divided by 9 equal 1? Doesn't that mean x, I wanted to stretch 2 units in the x direction, and the y, I wanted to stretch 3 y's in the y direction? And again, they didn't specify. I could make that between 0 and 2 pi, and that will trace 1 ellipse for me. And if I wanted to write that as a vector, again, not required for this course, but required by next class, it would look like this. Again, that's not for our course. Then we're going to review find the length. Well, we know how that works. I don't know why they didn't write this as XST and YFT, because that's chapter 6 really. But I thought, might as well. Find the length of the curve. L equal the integral of ds. That's the integral from 1 to 8 of the square root of 1 plus the derivative of that. So what's the derivative of that? That is 2/3 y to the negative 1/3. Right? dy. And if you really work this, I'm just gonna get you to clean that up a bit. That's 1 plus 4 over 3. So that is 2 over 3y to the 1/3. 9 when you square it to the 2/3. And if you get a common denominator, that pretty much does the trick. That's 1. That's 9 y to the 2/3 plus 4 divided by 9y to the 2/3 dy. And that is 1 to 8. Of course, if I say set up, do not solve, you're done right there. Mainly, that's what I'm going to say. But this is square root of 9y to the 2/3 plus 4 dy. And when you square root that, that's going to be 1/3. And that's y to the... So square root of 9y to the 2/3 is 3y to the 1/3. So that's really 1/3. And if you move this up, that's y to the negative 1/3. And now if you let u equal this, du will be negative 2/3. I'm sorry. If you let u equal this, if you let u equal 9y to the 2/3, the derivative of that will be y to the negative 1/3. That will work. And you go from there. And number 16, the same deal. I want to figure out the length of this. L equals, so we know that L equal the integral of ds. That's the integral. Well, everything's in terms of y, so no need to change that. Square root of, so 1 plus, if I take a derivative of x prime, that is, bring the power down, that's going to make that 1/4 y squared minus 1 over y squared. So we've seen this before. That is, if I actually FOIL this, I'll get y to the 4th over 16 minus 1/2 plus 1 over y to the 4th. And you'll notice the only thing that changed between those, when you combine those, you will get pretty much the same thing. The only difference, this minus will become a plus. Because when you add those, that's y to the 4th over 16. 1 minus 1/2 is 1/2 plus 1 over y to the 4th. So again, this is a review for chapter 6. I don't know why they threw that in here, but I thought, might as well. That's going to be y squared over 4 minus 1 over y squared. And of course, those cancel out. And you can do the rest. This is more like what this section is about. If I said find L equal, oops, that wasn't intended. L equal the integral of ds. With parametric equations, well, it's fairly simple. We're going to go from 0 to 1. And the derivative of that squared, that is 3t squared minus 12t. Why does that always happen? Plus the derivative of that, which is also 3t squared plus 12t squared. My guess, things are going to cancel out because that's like a minus b, a plus b. That's going to be the integral from 0 to 1 of the square root, and that is 9t to the 4th minus 2ab. That's 72t cubed plus 144t squared. And here you're going to get the same thing with a plus. Yeah, So something will cancel out. So I'm looking at the integral from 0 to 1. This is dt, of course. And that's going to be the square root of 9t to the 4th, 18t to the 4th, plus 288t squared. So obviously I could factor out a t squared. I could factor 18t squared out of both of those. But let's say you just took a t squared out without paying attention to anything else. I don't know what that is, so let's make that 18 and 288. And you know how that works. If you let u equal the inside, if you let u equal this, du will be a t dt, and you go from there. Now, almost done with this. There's one more to go before the end of this first review. If we take this and we rotate it about the y-axis, we know s equal the integral of 2 pi. If it's about the y-axis, x ds. If you remember that, that's provided in the formula sheet. So s is going to be the integral, again, from 1 over radical 2 to 1, the square root of the derivative of this, that's 2t. And what's the derivative of 1/2 t to the negative 1? That's negative 1 over 2t squared, plus the derivative of 4 square root of t, 1 over twice square root of t. So that is 2 divided by square root of t squared dt. Again, setup, do not solve, you're done right there. But I just want to show you a bit, set it up for you to solve. So that would be the integral 1 over radical 2 to 1, the square root. And if I FOIL those, what do I get? I get 4t squared minus 2ab. The 2's cancel out. 2 over t plus 1 over 4t squared. And this is going to be plus 4 over t. Oh, look at that. It worked out the same way again. I know you don't see it yet, but let me show you. So this was a perfect squared. The only thing that changes here, the 4t squared will be the same. The 1 over 4t squared will be the same. The only thing will change, if you take negative 2 of those plus 4 of those, you get positive 2 of those. So that means that's a perfect squared with this, but switching that sign. So this have came up a bit too many times by now. Hopefully we're seeing that. And this cancels that, and you proceed from there. So this is the conclusion of the first review that we have to do for this. I'd like you to look at numbers 1 through 21 odd.